Imagine facing death from the sky with no warning, no visible attacker and no human in control. This is the story of the first autonomous weapon in history, the Bat missile, and the terror it unleashed on Japanese sailors in 1945. Watch till the end to see how a single 180-pound missile changed the future of warfare forever. April 28, 1945. Over the East China Sea, 20 miles southeast of a Japanese convoy, Lieutenant Commander James Patterson gripped the controls of his PB-4Y2 privateer. At 15,000 feet, he watched the radar operator track 4 distant blips, representing ships his crew would never see. In the bomb bay rested 2 ASM-N-2 Bat missiles, weapons so advanced that even after multiple attacks, the Japanese Navy could not comprehend what struck them. The target bearing and range were the only words exchanged. The real battle was happening in circuits and radar screens. If you're fascinated by hidden WFU technology and the first automated weapons in history, make sure to like and subscribe to our channel. These missiles were not guided by human hands after release. They represented the first true step into automated warfare. Patterson would release them and turn for home, while his crew remained virtually spectators to destruction. The Bat missile's existence marked a shift in combat philosophy. Bravery and skill were no longer the sole determinants of success. American industrial capacity and technological innovation could deliver death from afar. Developed by the National Bureau of Standards under Dr. Hugh L. Dryden, who later became NASA's first deputy director, the BAT was fully autonomous. Unlike German radio-controlled glide bombs, it used its own radar to seek targets without human guidance. Weighing 1,080 pounds with a 10-foot wingspan and carrying a 1,000-pound warhead, the missile used analog computing, vacuum tubes, and servo motors to adjust its flight path. A remarkable achievement for 1945. The program began in January 1942, when the Navy recognized the need for standoff weapons capable of striking beyond anti-aircraft range. Engineers, physicists, and aerodynamicists across the United States, including Bell Labs specialists, collaborated on prototype development. By March 1943, testing had begun at Naval Air Station Patuxent River. America's ability to mass-produce these guided weapons would set it apart from Germany, whose small-scale, hand-built approach could never match the industrial might pouring into the Bat. If you're fascinated by hidden WE-2 technology and the first automated weapons in history, make sure to like and subscribe to our channel. The Bat missile made its combat debut on April 23, 1945, when VPB-109 Squadron attacked Japanese vessels at Balikpapan Harbor in Borneo. The first mission was plagued by technical failures. Both missiles malfunctioned, a reminder that even revolutionary weapons face teething problems. Despite setbacks, engineers and crews learned from these early attempts, adjusting designs and operational procedures. The promise of autonomous warfare remained, even as the technology struggled in real combat. The first confirmed Bat kill came on April 28, 1945, when VPB-109 sank a Japanese patrol vessel. The missile traveled roughly 9 miles from release to impact, with Patterson's aircraft already turning for home. For the Japanese sailors, death arrived silently from the sky without engines, planes, or warning. The psychological impact of facing a weapon that could think and act independently far exceeded the physical damage inflicted. Japanese naval personnel had no framework to understand the BAT missile. Trained in visual ship-to-ship combat and anti-aircraft defense, they faced an invisible and autonomous threat. Captured radar equipment confused Japanese engineers, who could identify components but not the system as a whole. The Bat revealed a technological chasm that went beyond weaponry. It highlighted the contrast between Japan's artisanal production and America's industrial capacity, which emphasized standardization, mass production, and precision engineering. By the end of May 1945, VPB-109 had achieved further successes. On May 1st, a second patrol vessel was sunk off Borneo, and on May 28th, the Japanese escort vessel Kaibokan Aoni was heavily damaged. While not sunk, the attack demonstrated the Bat's potential against defended targets. Despite technical limitations, radar confusion, humidity affecting electronics, and challenging environments, The psychological terror of unseen automated weapons left a lasting mark on Japanese sailors, a preview of the future of warfare. The Bat missile's development highlighted the extraordinary gap between American and Japanese industrial capabilities. By 1945, Japan had excelled in torpedo technology, night fighting tactics and naval training. Their Type 93 long-lance torpedo was arguably the best in the world, yet these refinements of existing technologies could not match America's creation of entirely new categories of weapons. Miniaturized radar, analog computing, gyroscopic stabilization, and automated control systems were integrated in the Bat, technologies Japan neither possessed nor could fully comprehend. American production emphasized standardization, allowing Bat missiles to be built quickly and efficiently with interchangeable components. Japan's approach remained largely artisanal, relying on hand-fitted parts crafted by skilled workers. This industrial difference meant that while Japan struggled to maintain existing equipment, America could rapidly produce complex guided weapons. In total, around 3,000 Bat missiles were manufactured, though only 420 would be deployed operationally before the war's end, a testament to the United States' ability to turn cutting-edge concepts into tangible tools of war. The psychological impact of the Bat was profound. Japanese sailors faced death from an unseen enemy, a threat that bypassed conventional anti-aircraft defenses. They had trained for visual combat, for courage in the face of attacking planes or torpedoes, but the Bat rendered these preparations almost meaningless. Reports from Japanese survivors describe confusion, helplessness, and a sense that they confronted something beyond ordinary combat, a glimpse into the future of automated warfare that no human valor could counter. Even when Bat missiles missed or failed, lessons learned from each launch led to improvements. Engineers refined radar discrimination to reduce confusion with land masses, improved electronics against humidity, and enhanced mechanical servos. Unlike Japan, which struggled to maintain aging equipment under wartime shortages, American development combined innovation with rapid adaptation. The Bat program's successes, though modest in terms of ships sunk, proved that autonomous guided weapons were not only possible, but could shape the psychological and tactical dimensions of modern naval warfare. The Bat missile's combat record, though limited, illustrated both innovation and the challenges of 1940s technology. Of the roughly 100 missiles fired in combat, only a fraction achieved hits. Factors such as radar confusion from islands, weather interference, and the limitations of vacuum tube electronics meant success depended on nearly perfect conditions. Despite this, every strike demonstrated the potential of autonomous systems, hinting at a future where machines, not humans, could select and engage targets with precision. VPB-109's missions showed the psychological dimension of warfare transformed. Ships struck by Bat missiles reported being hit from nowhere, without warning or visible attackers. The terror of an invisible, autonomous weapon left Japanese sailors demoralized and hesitant to sail even in areas untouched by Bat-equipped squadrons. The mere possibility of these guided weapons created strategic effects far beyond the 3 confirmed sinkings, influencing enemy behavior and operations long before an actual strike occurred. American engineers constantly refined the Bat in response to operational challenges. Humidity issues prompted improved sealing of electronics, while radar seeker errors led to better target discrimination. These adjustments were implemented across the production line, allowing each missile to benefit from lessons learned in real combat. Japanese forces, in contrast, struggled to maintain existing equipment, hampered by fuel shortages, degraded ammunition, and lack of replacement parts. The technological gap extended beyond weapons to the very capacity to sustain war. The Bat missile also revealed the stark contrast between American and Japanese approaches to warfare. Where the United States relied on industrial power and mechanical precision, Japan turned to extreme human sacrifice through the kamikaze program. Both approaches sought to overcome the opponent's strengths, yet only one embraced innovation to remove humans from immediate danger. The Bat represented a turning point. War would increasingly favor those who combined technology with production capacity, reshaping naval and aerial combat for decades to come. By mid-1945, the Bat missile had firmly established its role in the larger context of America's systematic pressure on Japan. Operation Starvation, B-29 bombing campaigns and submarine warfare had already decimated Japanese shipping. The BAT added another layer of threat, autonomous, invisible, and psychologically destabilizing. While the actual tonnage sunk was minimal, its presence amplified the effects of all other operations, making Japanese captains hesitant to sail even when conventional threats seemed absent. The BAT's technological design also highlighted lessons for the future. Its analog computers, vacuum tube electronics, and radar-guided systems were primitive by modern standards, yet they represented a complete proof of concept. The ability of a weapon to find and destroy a target without human control challenged traditional assumptions about skill, bravery, and the nature of naval warfare. America had demonstrated that engineering and industrial organization could achieve strategic results beyond the reach of human effort alone. Despite its successes, limitations were evident. The weapon worked best against isolated targets in open water. Congested coastal areas, poor weather, and moving targets often foiled its radar. Of the roughly 420 bats deployed, only about 100 were actually fired, and of these a small number achieved hits. Yet every launch provided critical operational data, informing improvements in electronics, target discrimination, and mechanical reliability. The Bat's failures were as important as its successes, shaping the trajectory of future guided missile programs. The psychological terror induced by the Bat also had long-term implications. Japanese sailors who survived attacks described confusion, helplessness, and a sense of facing an enemy beyond human comprehension. Death no longer arrived from a visible plane or torpedo. It came from the sky as an invisible, calculating machine. These experiences foreshadowed the modern era of precision-guided munitions, drones, and autonomous warfare, where the human element is increasingly removed from the mechanics of killing. The Bat missile also exposed the limitations of wartime technology in 1945. Its guidance relied on analog vacuum tube computers and mechanical servos that were prone to failure. Radar seekers could be confused by land masses or bad weather, and electrical components were vulnerable to humidity. Success required near-perfect conditions, clear skies, and isolated targets. Despite these challenges, the missile proved that autonomous, fire-and-forget weapons were feasible, laying the groundwork for all future guided munitions. The final Bat missile attacks occurred just days before Japan's surrender. On August 13, 1945, VPB-109 launched 2 missiles at presumed Japanese vessels, both missing their targets. This symbolic conclusion reflected the Bat's mixed combat record, operationally limited, yet strategically revolutionary. By war's end, only about 100 of the 420 deployed missiles had been fired, but the knowledge gained and technological breakthroughs achieved far outweighed the modest tactical results. Post-war testing continued until 1948, yielding disappointing results in reliability and precision. The Navy eventually retired the Bat by the early 1950s, yet the missile's importance as a technological demonstrator remained. Every American guided missile that followed, from the Sidewinder to the Tomahawk, traced its lineage to lessons learned from the Bat. Engineers who developed its guidance, including Dr. William Emlan, applied this knowledge to future systems, cementing the Bat's legacy as a pioneer in precision warfare. The broader historical impact of the Bat extended beyond technology. It forced militaries to reconsider strategy, tactics, and human roles in combat. Japanese naval officers interviewed after the war reported facing not just superior firepower, but a new conception of warfare itself. Weapons could act independently, threatening sailors in ways no training or courage could fully counter. This psychological dimension, fear of the unseen and uncomprehended, would define the future of automated combat and influence military thought for decades. The Bat missile's modest combat record, 3 confirmed ships sunk, belied its enormous strategic significance. While conventional attacks sank far more vessels, the Bat demonstrated a fundamental shift. War could now be conducted by machines acting independently of human control. This shift changed naval tactics, psychological expectations, and the very meaning of skill in combat. Soldiers and sailors now faced a world where victory depended as much on technology as on bravery. The development of the BT also showcased the advantages of American industrial philosophy. When early missiles encountered problems, engineers could quickly implement fixes across production lines. Humidity issues were addressed with improved sealing, and radar confusion errors were corrected with better discrimination systems. This ability to iterate and scale technology rapidly gave America a decisive edge over Japan, which struggled to maintain even its conventional weapons under material shortages and logistical constraints. Facing the Bat, Japanese sailors experienced an unprecedented psychological strain. Death arrived silently, without a visible attacker or warning, eroding morale and trust in conventional defense measures. The weapon's autonomy created fear that extended far beyond its physical destruction. Even when no missile was present, the threat alone shaped Japanese naval behavior, preventing ships from sailing or forcing them to operate more cautiously, giving American forces an operational advantage far beyond the missile's tactical success. Ultimately, the Bat missile represented the collision of technology and warfare philosophy. America embraced industrial innovation to create weapons that removed humans from immediate danger. Japan responded with the kamikaze program, relying on human sacrifice to counter technological superiority. This contrast reflected broader civilizational approaches, mechanical precision versus spiritual resolve. The Bat symbolized the future of warfare, where algorithms, sensors, and autonomous systems would gradually redefine how conflicts were fought and won. The Bat missile's existence highlighted the broader American strategy of technological domination over Japan. By April 1945, Japanese coastal shipping had already been decimated by Operation Starvation, B-29 mine-laying missions, and relentless submarine attacks. The Bat added an additional layer of pressure, a weapon that struck without warning, invisible to the enemy, and capable of forcing psychological paralysis. Even with only 3 confirmed sinkings, the missile amplified the overall effectiveness of Allied operations and reinforced America's dominance in industrialized warfare. The missile's technical limitations did not obscure its conceptual breakthrough. Its analog computing, radar guidance, and servo-controlled flight surfaces proved that autonomous weaponry was possible. These systems could calculate trajectories, identify targets, and execute strikes without human intervention, a profound step forward in military science. The lessons learned informed future missile programs, laying the foundation for precision-guided munitions that would eventually dominate conflicts in Korea, Vietnam, and the Gulf War. The psychological impact on Japanese naval personnel was profound. Traditional combat doctrines, centered on human courage, visual detection, and tactical skill, were ineffective against a weapon that required no pilot or crew. Survivors reported confusion, helplessness, and a sense that they were being hunted by an unseen, calculating adversary. This experience foreshadowed modern warfare, where precision strikes, drones, and autonomous systems can disrupt operations and demoralize forces without direct engagement. Even in failure, the Bat provided valuable operational lessons. Post-war analysis revealed that the missile's radar systems struggled with land clutter, humidity, and congested waters. Each miss or malfunction informed refinements for subsequent programs, teaching engineers the importance of robust electronics, target discrimination, and mechanical reliability. The Bat's legacy extended far beyond its combat record, influencing missile guidance systems, drone technology, and the broader philosophy of removing humans from direct danger in war. The Bat missile's place in history lies not in the number of ships it sank, but in the revolutionary concept it introduced. It was the first autonomous weapon to kill without human guidance after launch, signaling the dawn of a new era in warfare. For the Japanese sailors who faced it, death arrived from empty skies, delivered by machines that could see, calculate, and strike faster than humans. Their confusion and helplessness marked humanity's first encounter with automated combat, a prelude to decades of precision-guided conflicts. American industrial capacity and technological ingenuity were crucial to the BAT's creation. The $12 million investment, roughly $180 million in today's dollars, funded a program that produced 3,000 missiles in just 3 years. While only a few achieved combat success, the lessons learned influenced every subsequent guided missile project. Engineers applied their experiences to develop more reliable electronics, improved radar guidance and refined servo mechanisms, shaping the trajectory of Cold War missile development and modern autonomous weaponry. The ethical and psychological dimensions introduced by the Bat remain relevant today. It was the first weapon to remove human decision-making from lethal force, raising questions about responsibility and the morality of automated killing. Japanese officers' post-war interviews revealed a profound sense of disorientation, realizing they were facing not merely superior firepower, but an entirely different conception of warfare. The Bat demonstrated that technological superiority could nullify human skill, bravery, and traditional tactical thinking. In conclusion, the Bat missile's combat record of 3 small ships sunk may seem modest, but its historical significance is immense. It proved that guided weapons could function independently, foreshadowed modern drone warfare, and set a precedent for precision, automation, and technological innovation in military strategy. The missile flew into history, carrying both explosives and the promise of a new age of warfare, an era we continue to navigate today. The first casualties of automated weapons were Japanese sailors who never saw their attackers, yet their fate heralded the future of combat. Even after Japan's surrender, the Bat missile remained a symbol of technological innovation and strategic foresight. American military engineers continued testing and refining the missile until 1948, exploring its potential and limitations. Despite disappointing post-war results, the program produced invaluable insights into autonomous targeting, radar guidance, and analog computing. The lessons learned would inform the Cold War arms race and set the stage for the first generation of smart weapons. The program also illustrated the scale and ambition of American wartime industrial capacity. Thousands of scientists, engineers, and factory workers collaborated to produce thousands of missiles in just a few years. The rapid development and deployment of the Bat highlighted America's ability to solve complex engineering problems under immense pressure. Each failure, adjustment, and success reinforced the concept that innovation, production, and adaptability could shape the outcomes of global conflict. Psychologically, the Bat missile left a lasting imprint on military doctrine. Japanese officers' experiences with weapons that acted independently of human control forced military planners worldwide to reconsider the role of automation in combat. Soldiers had to prepare for enemies that were no longer bound by traditional limitations. The weapon's legacy influenced strategies not only in missile development, but also in drone warfare, precision airstrikes, and modern naval tactics. Ultimately, the Bat missile represents more than a weapon. It is a historical milestone. Its modest combat record of 3 ships sunk conceals a far greater achievement, proving that autonomous weapons could function in real combat. It bridged the gap between concept and practical application, ushering in a new era where the future of warfare would depend increasingly on technology, precision, and machines capable of independent action. The human cost was minimal compared to the psychological and strategic impact, marking the first step into the age of automated warfare. The influence of the Bat missile extended far beyond World War II, shaping the early Cold War era. American engineers and military planners studied every aspect of its design, using the lessons to create more sophisticated guided weapons. The principles of autonomous targeting, radar guidance, and mechanical control systems learned from the Bat would later appear in the Sidewinder air-to-air missile, Tomahawk cruise missiles, and other precision-guided munitions. Its legacy became a foundation for modern warfare, where technology could act faster and more accurately than human operators. During the Cold War, the U.S. military continued to prioritize weapons that minimized human risk, while maximizing operational efficiency. The Bat demonstrated the value of removing human pilots from dangerous missions, inspiring a shift toward standoff attacks and unmanned systems. Engineers realized that automation could enhance survivability while maintaining lethality, Even decades later, the fundamental concepts pioneered by the Bat still underpin contemporary drone strikes, autonomous naval missiles and advanced smart bombs. The psychological lessons of the Bat missile remained equally relevant. By creating fear and uncertainty in the minds of enemy sailors, it showed that warfare was not just physical destruction, but also mental domination. Military strategists began to understand that the mere presence of autonomous weapons could deter actions, slow enemy operations, and influence decision-making. The Bat foreshadowed the modern battlefield, where precision, invisibility, and automation have replaced massed formations and traditional bravery as decisive factors in combat. Finally, the Bat missile's story illustrates a broader lesson about innovation and risk. America invested heavily in a weapon that achieved minimal tactical results during the war, yet the knowledge gained was invaluable. The courage to experiment with revolutionary technology, despite uncertain outcomes, shaped the future of armed conflict. From its modest combat record in 1945 to its lasting impact on global military strategy, the Bat missile stands as a testament to human ingenuity and the transformative power of science in warfare. The Bat missile's pioneering role also sparked early debates about the ethics of autonomous killing. For the first time in history, a weapon could select and engage targets without human intervention. Military ethicists and strategists began questioning the implications. Who was responsible for the decisions made by a machine? Could the removal of human judgment from lethal force erode accountability in warfare? These questions, first raised in 1945, resonate strongly today with the proliferation of drones and AI-guided weapons. Technological innovation inspired by the Bat accelerated rapidly in the post-war years. Analog computing, radar guidance, and servo mechanisms were refined and miniaturized for new missile systems. Lessons learned from failures, missiles missing targets due to land interference, humidity, or mechanical errors, drove improvements that increased reliability and accuracy. Each iteration brought militaries closer to a future where human skill was supplemented, or even replaced by precise, automated systems capable of operating under extreme conditions. The Bat also reshaped military doctrine and strategic thinking. Planners recognized that weapons capable of autonomous action could influence both the physical and psychological landscape of warfare. Enemy forces could be paralyzed not only by the threat of destruction, but by uncertainty and fear of invisible attacks. This understanding led to the development of integrated combat systems, combining human decision-making with automated precision strikes, a precursor to modern network-centric warfare and smart weapons. Ultimately, the Bat missile's legacy transcends its limited wartime success. It marked the start of a new era where machines became active participants in combat, changing the nature of risk, responsibility, and strategy. The psychological trauma inflicted on Japanese sailors foreshadowed a future battlefield dominated by precision, automation, and invisibility. The weapon's conceptual breakthrough paved the way for decades of innovation, influencing everything from Cold War missiles to today's armed drones and autonomous systems.